Hi, and welcome to Help Systems Cut Through IBM I Security Confusion. My name is Amy Williams. I'm a senior security consultant with Help Systems with my primary focus on the IBM I infrastructure. Today we'll be talking about some aspects you may not have experienced on the IBM I, or you may have heard about them and just aren't really sure what they mean. We'll start with adoptive authority. We'll move on to profile swaps and how those differ from adoptive authority. We'll touch on how to secure printer output and the different special authorities that can affect how that security is configured. And last, we'll touch on application administration, which has some changes coming to it with the new Navigator and the security around function usage. So let's get started. Adoptive authority will temporarily grant authority to a process or a user profile. When adoptive authority is used, it will not include command line access or the authorities of the program owning groups. Things that you can use adoptive authority for are allowing users to create user profiles, access to sensitive data, submitting processes that their general profile doesn't have authority to do. When looking at a program, there are two attributes that we will observe to determine if the program is adopting authority itself or if it has access to adopt authority from higher in the call stack. So to tell if a program is adopting authority, you want to look at the user profile parameter. Use adopted authority is the parameter you want to look at. It's where we look at first because we want to know if the program adopts authority. However, all that parameter means is that we can adopt authority from higher in the call stack. The user profile attribute of star owner means that this program is able to adopt authority by the program owner. So we're going to walk through some of these examples so you can see how this affects different programs being executed. So we have an initial program. This initial program is owned by app owner, and the program's configured to adopt that application owner authority. So the authority checked on that initial program is only the user's authority because there's nothing else in the call stack. But when program A now calls another program or a menu option is taken, the authority to that program, first, the user profile will be examined to see if it has authority to that program. And then next, because program A adopts owner authority, the owner authority will be examined. Then when program B attempts to access another object, only the user authority will be examined at that program level. But because use adopt authority yes is set, it can look back in the stack and see if app owner is available, and it is. Let's look at another example. So program C, we're going to elevate this time, and we're going to grant QSEC offer authority to this program. So when this program executes, the first thing it looks at is the user profile authorities. Then, because the user profile on the program is configured to star owner, it's going to see if QSEC offer has authority to the objects. And if QSEC offer doesn't have authority, and we all know that QSEC offer has all authority, but if it doesn't, or if the owner's not QSEC offer, it's going to look and check up the stack, in this case app owner, to see if app owner has the authority to the object or to the function that is trying to be executed by this program. Let's take it one level deeper. So we have the same call stack. We've started with our initial program, program A. It's adopting app owner. So it's running under app owner authority. Program B is running under the user's authority, and possibly under app owner authority also, because a use adopted authority flag is set to yes. When program B now calls program D, or yet another menu option is taken, this program happens to be owned by a different owner. So app owner 2 owns this, and program D is adopting authority, and it's allowed to adopt authority from higher in the stack. So when it executes, the user profile authorities are looked at, then app owner 2, and then app owner. All of those authorities can be accessed to eventually make whatever the request is successful by that program. So what if we take a menu option that presents a command line? We want to ensure that the user that is presented that command line is only working under their own authority. So in this instance, program E, owned by app owner 2, but the user profile attribute is set to star user. So it's not adopting the owner authority in this program. So next, we would look to see if it can adopt authority from higher in the call stack. Use adopted authority is set to star no. So in this case, when this program executes, it is only going to be able to look at the user profile authority. So program E is going to stop that authority from propagating down the call stack because the user profile is star user and the use adopted authority is set to star no. So in the case of program C, when another menu option is taken, the next program is possibly going to have access to QSEC offer authority still. So the way we have this configured is the app owner is the owner, user profile is the user. Okay, great. The program's not adopting authority from the application owner. But wait, the use adopted authority flag is set to star yes, which means it can go back in the call stack as far as it's allowed and see if it can gain enough authority, which in this case means it'll check the user profile. It will then check the QSEC offer profile because that's higher in the stack and use adopted authority is yes. And then it'll check the app owner. This is what we don't ever want to do. This can allow exploits of our data, access to options that aren't intended, expose a command line to an administrative level user profile. So when you're doing a remediation, when you're evaluating the authority of your objects in your programs, and you're looking at adoptive authority as a solution, absolutely is a fantastic way to move forward. But be cautious. If you have a program that's set to use adopted authority, yes, and you have a program higher in the stack that is also adopting authority of an elevated profile, this could allow elevated authority to continue through the call stack and grant users unintended authority. So what are some of the limitations of adopted authority? So it is stack-based. We've talked about that quite a bit. So it's only active and only available while that call stack and that program is in the stack. Adopted authority is not going to continue on when you submit a job because now that submitted job has a new call stack because it started from a new program. Doesn't cross over with FTP submitted commands, remote commands, or DDM remote commands. Those all have new call stacks, so they won't be able to inherit any of the authority in the previous call stack or previous programs. Adopted authority is also ignored by the IFS. So you can't grant elevated authority to access IFS objects by changing a program that accesses the IFS to use owner authority. And then lastly, when you are using that owner's authority, if that owning profile is configured to have limited capabilities, no, meaning it has a command line, that authority is not adopted. So in the example I spoke of, where the program presented a command line and had adoptive authority in place, that's only going to be a risk if the user profile itself has command line access. When we're talking about adoptive authority, we still want to use least privilege fundamentally when we're granting access. We don't want to just go through and have all of our programs owned by an authoritative user and have them all adopt authority. That could expose a lot of data. It could expose a lot of parts of your system and functionality that's not intended to be accessible. In the short, don't use an all object profile unless absolutely required to own a program. When providing authority of an elevated user that has all object, has secadmin, has iosysconfig, make sure they're single function programs. That's the only thing that program's doing, that it can't expose a command line to a command line user that day to day only has spool control or only has job control. And now you present them a command line that's adopting elevated authority. Now they can change system values. They can access other objects. They can change authority to sensitive files. So be very cautious when you're configuring these programs to adopt authority. But it can be useful in resetting user profiles and passwords, enabling devices, running your startup program at IPL, or submitting jobs that need specific users to run those jobs. These are all ways that you can stay at least privilege, not having to grant elevated privileges to your entire user community or even just a larger set of your user community, and still be able to run high-level functions that do require elevated access. So we've talked about some of the risks of adoptive authority. Again, least privilege should always be considered when granting elevated privileges. Only grant the elevated privileges that are required. If a program does get misconfigured, it can grant more authority than appropriate, more authority than you intended. So ensure that you understand how those programs are being invoked and what those call stacks look like. And then when you're calling a program that either presents a command line, programs that are sending commands to another program, or revealing sensitive data, you want to ensure that the appropriate authority is being granted. If you have a program that just has a prompt and they can type in text and then that text is taken and passed to a program that executes a command. So it's not a true command line. So limited capabilities has nothing to do with the screen that they're on. When they press enter and that text string, that command, is passed to that command program, you want to ensure that that command program is not granting them access that they shouldn't have. So if they're only supposed to be allowed to submit a specific job, work with a specific out queue, whatever it is, make sure that that program that's accepting that command string isn't elevating them so high that they could possibly create a user profile, or they could delete files off of your system. All things to take into consideration when using adoptive authority. Now, I've talked quite a bit about the search order of authority and how the system will find enough authority when those programs are being called to access the function they're trying to access. So let's dive into that a little bit deeper. When a program is invoked, when it goes after the objects that are required for what that process is, the way that it finds enough authority to do that is by evaluating the authority available to the user profile. It's going to check the user's authority. If the user has all object authority directly on the user profile, that stops. The user profile is granted access and the process moves on. If the user does not have all object, The next thing that is checked is the private authorities on the objects, and then the private authorities on the authorization list if the objects are being secured by an authorization list. If none of those provide enough authority, the groups for that user profile are also checked. Again, the first thing that's checked is if a group has all object. If it does, search stops, access is granted, you move on. Then it checks to see if it's a primary group on the objects and has access. Then the private authorities of the object itself, and lastly, the authorization list private authorities. And it does that for each and every group up to all 16 that a user profile could be a member of. Authority is cumulative. So if one group has job control and another group has IOsysconfig, and those are the special authorities needed to perform a function, the user will have that authority from both of those groups. So if we come up empty and none of the groups have authority, the next thing that gets checked is public authority. And this is the authority that every user profile has on the system. It's referred to as public. First, public on the object itself will be evaluated, and then if the authority on the object is pointing to an authorization list, then the authority for public on the authorization list securing the object will be looked at. So if you've gone through and you've secured your objects with authorization lists and you've set public to exclude on all of those authorization lists, that's great. Ensure that the objects themselves, their public authority is pointing to that authorization list with a star AUTL value and not change or all, because that private authority for public on the object itself is what will be evaluated first before the authorization list. It can be a gotcha when you're trying to secure things or when you're trying to find out how someone got access to something they weren't supposed to or didn't have access to something they were supposed to, because public got set to exclude in the private authorities, and on the authorization list, public has use. So lastly, public doesn't have authority, adopted authority is checked. And when that adopted authority check runs, if it's not sufficient, that is when the authority failure will be logged into the audit journal and the job will possibly fail. So just to step you through, every time an object is accessed, the authority that's checked is the user profile's authority first, then all of the groups if there are any for the user, then public, and then the adopted authority can take effect. It's that last chance that's given to the process to try and access the objects that are required. So let's move into another way that you can grant elevated authority or different authorities to a user profile temporarily, and that's through a profile swap. A profile swap actually changes the user of the job underneath the covers. Every time you sign on to the system through either a 5250 or an FTP or an ODBC session, all of those jobs that accept in that connection and then start your interactive session for 5250 or start your ODBC session, those listening jobs are system jobs running under QUser. You swap from QUser into your profile for each of those jobs. So profile swaps are used throughout the OS. So in this example we have our user 1, has the group manager 1 in accounting, no special authorities, has limited capabilities, and only has job BAS auditing, meaning it's going to log the start and the end of the jobs. When that profile swaps into the sales profile, the groups go away. And now it's the sales and the marketing groups that are available. And now job control, special authorities available. So these are similar to when we adopt authority, but it's not cumulative. It's only what sales and marketing has now. Job controls granted, limited capabilities is partial. Now you've granted command line access by doing a profile swap. And then the auditing values can also change. So in this case, with command line access, command auditing has been turned on for this profile. When you look at the job is going to look exactly the same. It's still going to say user 1, even though user 1 has been swapped into user 2. Another example of this that I mentioned are ODBC jobs. So you can see in this example job, a secure ODBC connection was made to the QZDA SSINIT job that's running under QUser. But when we look at the current user of the job, it's user 1. And that was done with a profile swap. So when that profile swap happens, QUser is moved out of the job and user 1 is moved in with all of the access that user 1 has. Some of the things that will happen when you swap those profiles, and there's requirements to be able to swap those profiles depending on the API that's used. So some of that is the password must be known, or you have to have use authority to the user profile that you're swapping into. This API can create a profile handle. That profile handle is only going to be good for that job. Some other methods that can be used for different purposes. A profile token can be created and can be passed between programs. Also, the set GID or the set UID methods can be used, which are very similar to methods used in Unix and Linux systems. When we look in the audit journal to identify what profile, what user profile actually executed and made the request, was running the process, there's multiple fields we're going to want to examine. So for this example, I use the create entries, the audit journal. So the CO user is the job user. And then the CO USPF field is the current user of the job. So in the case of that DASDO-NIT, we would have seen the CO user being Q user and the CO USPF user profile being user 1. And the objects created during that ODBC connection would be created by user 1, not Q user. So if we look at some differences between adoptive authority, configuration of a program, and doing a profile swap using system APIs, with adoptive authority, that authority is available so long as the program's in the call stack. With a profile swap, the authority is available until the profile is either swapped back to or the job ends. With adoptive authority, the current user always stays the current user. So you don't see that difference in the job. It's always the same user when the program is being utilized to adopt authority. Profile swap, the actual current user of the job is changed. When looking at the audit journal, you can always examine the USPF field in the entries. That's going to be the user that was executing the function. It may appear with adopted authority that that user shouldn't have had authority to do that. So you'll have to also examine the program fields. With a profile swap, there may be multiple user fields that you'll need to examine depending on the audit entry you're examining. When the program owner's group authority is not available, meaning it's no longer in the call stack, the program has stopped executing. And in this case, we're really talking about when a job gets submitted, that chain, that call stack chain is broken. The authority is no longer available during an adopted authority. With profile swap, the profile groups can also be swapped in. So you could acquire both the users groups and the swapped in users groups when doing those swaps. With an adoptive authority, with the programs, limited capability is not adopted. That attribute of the program owner is not inherited. When you do a profile swap, limited capability, whether it is granting command line access with limited capability no, or it is taking command line access away with limited capability yes, that attribute is swapped in. Adoptive authority with programs is ignored by the IFS. It does not cross between the QSys lib file system and the root file system. With profile swap, because you're using user authority, that does access the IFS just as if you had used that user profile to originally authenticate to the system. And then lastly, and this is something we'll go into deeper in this next section, with spooled files, when you adopt an authority with a program, because the user hasn't changed in the job, any spooled files that are created during that job are owned by the current user. However, when you use a profile swap, if during that swap spooled files are generated through whatever means, those spooled files are owned by that swapped in user. So the original user that swapped will not have access to those spooled files without taking some extra steps in securing and allowing that type of access to the outqueues. So these are some considerations when you're looking at which method is the best method for the process that you're trying to invoke. So let's talk some more about spooled output. So printed output, spooled files that get converted into IFS stream files. These all start in a outqueue of some configuration. Some still print to printers. Many are just holding spaces. And some are temporary landing places until they're converted into a stream file and then deleted from the outqueue. So we're going to step through each of the special authorities and then deep dive into spool control. So audit grants you the ability to change authority, auditing configuration of objects, so whether those objects are being audited or not. IOSysConfig allows you to create devices, create line descriptions, and also allows you to either create or delete shares. You can also change if a share is read-write or read-only with IOSysConfig Special Authority. Job control allows you to manage any job on the system, and we'll talk about some additional advantages that job control has when it comes to outqueues. SaveSys has the ability to save any object on the system, regardless if you have authority to those objects or not. You can save those objects, and you can also restore objects to the system. With SecAdmin, management of user profiles. Star Service allows you to use service tools, start a trace on the system, and then spool control is access to every spooled file on the system, regardless of your authority to the outqueue, regardless of your other special authorities. And then all object, of course, is access to every object. And it is not possible to truly prevent an all object user from accessing any object on the system. So when we talk about spool file security, there are two special authorities that come into play. We have spool control and we have job control. And then additionally, we have the user's authority to the out queue itself, and we also have the attributes of the out queue that work together: display data, the authority check, and operator control. And all of these factors come into play in trying to determine how an out queue is secured and who has access to it. With spool control, it is truly the equivalent of all object for spooled files. The user profile has spool control. That user profile has access to all spooled output on the system, regardless of the configuration of the out queue. And when we talk about spooled data, we're talking about payrolls. We're talking about accounts receivable reports, GL reports, customer account information. Could be very sensitive information that's residing in these spooled files. Spool control can grant someone access to any of those. Additionally, job control, in the case of the operator control attribute of an out queue, which by default is set to yes, anyone with job control additionally has the access to manipulate out queues and manipulate the spooled files. So let's look at some of these other flags on the out queues. So display data. This says who can see the output on the out queue. It can control who has access to display the spool files, copy them, send them, change their attributes. If display data is no, which is the default, then one of the other pieces must be true for users to be able to display, send, or copy a spooled file. Operator control is set to yes, and the user has job control. The authority check is set to data authority, and the user has change to the out queue. Or the authority check is set to owner, and the user is trying to perform an operation that owns the out queue. And then if display data is yes, users that have at least read access to the output queue can display, copy, or send a spool file owned by anyone else on the system to any other out queue or printer. And then always remember, public defaults to change. So if we go back to our search criteria for the authority to gain enough access to an object, if public is changed, eventually any user on the system would have access to that data and that spooled output. And lastly, if display data is set to owner, then only the owning profile of the out queue, where a user with spool control special authority can access the spooled output in that out queue, along with, if operator control is yes, the same still goes with job control, and they can still manage the out queue. If display data is star owner, then only the owner of the spooled file or a user with spool control authority can display, copy, send, or move that file. Even with operator control set to yes, job control will only give the ability to manage the out queue, start and stop a remote writer, hold items on the, or hold the out queue, but will not grant access to display that data. So when we talk about the authority check, this changes who can manipulate the spooled files within the out queue. If the authority check is star owner, then only the owner of the out queue can manage the spooled files. If the authority check is data authority, then users that have read, add, or delete authority to the out queue can manage the spooled files owned by others. And additionally, if opper controlled is yes, anyone with job control can also manipulate any of those files. This sums up to basically be a lot of options. So you have an out queue that has shared output that you only want a managing profile to access all the output. So we have QSEC offer owning the out queue. Display data is set to no. The authority check is set to data authority. Opera control is set to no. And management user is allowed. Change private authority to the out queue. This instance, that management user would be able to manage the spooled files within that out queue. Option 2, it's shared output, and the operators can move, delete, copy, send the spooled files. QSEC offer owns the out queue. Display data is still set to no. Authority check is still set to data authority. But in this instance, opera control is set to yes, and operators have been granted job control special authority. They can move the spooled files, they can put them on hold, they can delete the spooled files and clean up out queues. So this is two really clean examples of when you need to restrict access to out queues except for a certain group of people, or you need to allow access to a larger group of people, and ways that you can do that. There's detail in the security reference guide about which authorities are needed to either the output queue itself or special authorities, and the authority to the spooled files. So you can define and decide what the right combination is for your out queues, especially when those out queues contain sensitive data, whether that's personally identifiable information, if it's customer lists, if it's any type of proprietary information that should not necessarily be shared amongst any user that has access to your system. Think about securing that out queue so that only the users that are intended to have access to that data are granted that access. Function usage, also known as application administration, and this is one of those changes that I mentioned at the beginning of the presentation that are coming with the new Navigator. No longer is it called application administration, and it's not located under system management. It now has its own place in Navigator, and it is called function usage. So when you open the new Navigator, under the security subset, you'll find function usage. Function usage can be used to secure the features within the new Navigator to ensure that users only have access to the features that they should be allowed access to. You can also secure FTP at a very on-off level. This is not an IP decision making. It is simply if your user profile is not allowed to use FTP, you will be stopped from using FTP. The same for ODBC. And with ODBC, it's a little tricky because they actually called it the toolbox. But you can secure ODBC access also through function usage and those restrictions or those access allows. Another change that's coming is that the Navigator options were all allowed by default. After the PTFs in April, that's now being changed to a deny by default, and you must go in and grant access individually. So other things that you can secure, the file system, which allows you to create or delete shares or change those shares attributes from being read-only to read-write or vice versa. Network, which allows access to all of the server jobs, IP configurations. Security, which not only includes function usage, but also includes user profiles and authorization lists. And lastly, system, which grants access to disk statuses and the SQL services. So as an example, we're going to restrict access to the file system. So from the function usage list, you would right-click on Nav File System and select Change. That will bring up an additional screen where you can browse for the profiles. So here I used a value of F. It brought up all of my profiles that started with F. I was able to select them all. And then I was able to click Access Denied, the Add button underneath. So now all three of those profiles are now denied access to the file system section of the new Navigator. Another example is access to all object job logs. This is a common one. So if you're not familiar with this function, if you have operators that should be able to look at job errors, job logs that are active jobs, not spooled files. Spooled file job log is a spooled file. This is talking about an active job that's being run by a user profile that has all object. By default, only other all object users can view those interactive job logs or active job logs, because it could be a batch job that's being run by an all object user profile. If you want operators or any other users that do not have all object to have access to observe an all object user's job log while the job is active, you must allow them through function usage to be allowed under the function ID of the IBM access all object job log. Same fundamental, but instead of adding them to the access denied list, I added it to the access allowed. The other attribute that you can observe is the profiles allowed or denied. This has taken the place of the customization indicator. So it used to be in the old Navigator, if it was customized and you could remove the customization, they've changed that to now say, are profiles being allowed and denied? So once you have added entries to that function, that profiles allowed and denied will say yes. And then I also briefly mentioned that the shipped value for the secure Navigator functions is being changed from allowed. And after the PTFs in April, May of 2022, the default will be denied. So something to be aware of if you apply PTFs and now all of a sudden users that used to have access to Navigator functions no longer have that access. Here is a quick view of the listed PTFs and their release dates. I've also included the link above for you to be able to access this information. So we've gone through a lot of information today, and I appreciate your attention to this. Hopefully we've answered some questions you may have had. A great way to find out just how secure your IBM I system is using our free security scan. This will show you just how many user profiles actually have spool control or job control. It also includes an hour of time with one of our security consultants. This can be a great way to start that priority list of items to be addressed on your systems. We have some time left today, so if you have any questions, please put them in the Q&A. And we have a few questions here. The first is about adoptive authority. Can you use adoptive authority to access files in the IFS? You can't use program adoptive authority. In those instances, you would want to use the profile swap APIs. The next question we have is about preventing adoptive authority by configuring the programs. You can by ensuring the programs are configured to user profile star user and the adoptive authority flag is set to no. And that will prevent that adoptive authority from being used at that program and anywhere further down in the stack from that program. We are coming up on time today, so if there's any questions that I missed in the chat, we will reach back out to you separately. This session will be posted on the website and you'll receive a link via email. Thank you again for joining me today for this, and hopefully we answered some of those burning questions about IBM I security.